Hey everybody, in this video I will be talking about the states of matter. As I said in the previous video, matter is anything that has mass, or weighable stuff, and volume, or having the quality of taking up space. Volume is easy to understand, but we need to clear up one thing. What is the difference between weight and mass? Mass is like the stuff, and weight is the force exerted by the stuff. For example, you have a mass because you are made of stuff, but your weight is not your stuff. Your weight is the force exerted by your stuff on the ground due to gravity. You usually measure mass with a unit called a kilogram, kg, and you usually measure weight in newtons or pounds, lbs. Matter can come in many different forms. We'll talk about 4 of them, although you'll encounter most of the time only 3 of them: solids, liquids, and gases. The first state of matter is a solid. A solid, labeled right there, is matter that has a definite shape and a definite volume. It has a definite volume for the most part, since the volume of a solid can change depending on the pressure, but that is usually negligible, meaning that it can be ignored since the change under a lot of pressure is so small. For example, ice, like in an ice cube, is a solid because it has a definite shape and volume, at least until it melts into water. Now, that leads us into the second state of matter, which is a liquid, labeled L in our diagram. A liquid is a matter that does not have a definite shape but has a definite volume for the most part, since, like a solid, a liquid can slightly change in volume under high pressure, but we say that this is negligible since the change is so tiny. Water is a liquid because even if you put it in a different container, it'll still fill up the same space or the same volume, but it will be shaped differently. The third state of matter is a gas. A gas has no definite shape nor volume. For example, imagine the gas in a can of soda. When you open the can, all the gas inside it will escape and expand into the room. As a result, gases don't have a definite shape or volume. Another great example of a gas is water vapor, which is the gaseous form of water when it is boiled. We use the letter G to denote gases. Now, we have the rarest form of all. The fourth state of matter is plasma. Well, it's just called plasma. Plasma is rare because it can only be found in extremely high temperatures or through electricity with very high voltages. If you imagine yourself cutting matter until you get to the smallest form of matter possible, you get something called an atom. So we're going to trail into another conversation about the atom right here, atom. That's an atom. The atom is the smallest unit that makes up all matter. Think of an atom as the smallest building block, like a toy Lego. These atoms are made of a positively charged nucleus, this positively charged nucleus right there, and negatively charged electrons, these E minuses that you see that surround the positive nucleus in the middle. In very high temperatures or high voltages, these atoms will become unstable and they'll break up into positively charged nuclei and negatively charged electrons, like right here. These positively charged nuclei and these negatively charged electrons. So if you've ever seen a neon light before, like, let me try to draw a neon light right here. Let's just say this is a neon light, and it's bright and shooting out light. These neon lights have a gas called neon, which when exposed to electricity with high enough voltage will turn into a plasma and glow vibrantly. Because the sun is so hot, most of the sun is actually made of plasma. Now, let's go back to the other slide. As you crank up the heat and increase the temperature, or energy, or heat, whatever you want to call it, the states of matter move in the following order: solid, liquid, gas, and plasma. And again, you'll only see the first three in chemistry. Let's jump back to solids. There are two types of solids I'd like to talk about. A crystalline solid is made up of atoms, or building blocks, that are arranged in an orderly fashion. They usually have sharp melting points, or the point at which they melt. An example of a crystalline solid would be a diamond. An amorphous solid is made up of atoms that are not arranged in an orderly fashion, as you can see right here. These atoms are not perfectly arranged like these ones are. These ones are just kind of smushed together, if you can think of it that way. These amorphous solids have a melting point range, meaning that they usually melt over a wide range of temperatures. So let's just say this is the temperature and this is the range at which they melt. An example of this would be butter, since butter doesn't just all turn to liquid at one temperature. It undergoes melting from the lower end of the melting point and finishes when it reaches the other side of the melting point. And in contrast, for diamond, it melts in basically at one temperature, which is this point right here. Now let's try identifying some states of matter. In the first image, we have a sample of bromine in the flask. What states of matter can we find in this image? Well, we see some clouds that don't have a definite shape nor volume, so these are most likely gases. Now, what about this dark spot in the flask? Well, since this dark spot takes up the shape of the flask but doesn't seem to change its volume in the process, meaning that it has the same volume, this is most likely a liquid. So bromine exists as both a liquid and gas in this image. Now, what about emerald? Well, clearly emerald has a definite volume and shape, so it's a solid. What type of solid is it? Well, it's a crystalline solid. Most crystals, like the emerald shown here, are crystalline solids because crystalline solids have a very solid shape. They are very durable, and if you try to touch them, they will not deform or change shape because they have a crystalline structure that's very stable and orderly. Now, in contrast, amorphous solids are less stable and more prone to deformation. For example, when you touch butter, butter will deform, and this is due to the fact that the atoms in amorphous solids are less organized and more disorderly. Now, let's look at our final example, our calculator. Well, a calculator has a definite shape and volume, so it's a solid. That's all for now.